Welcome to Train Signal. This is the Configuring HTTP lesson in the Forefront Threat Management Gateway 2010 training course. We're going to cover some HTTP settings and configuration options that you have at your disposal in Threat Management Gateway, starting with the purpose of what's called the HTTP filter. From there, we'll move on to discuss some common scenarios with regard to the HTTP filter, and then we'll discuss some HTTP policy settings in general. After that, we'll move on to configuring HTTP compression, which is a way that you can save a little bit of money on bandwidth costs. And we'll wrap up with an overview discussion of what's called diffserv. At GlobalMantic, peer-to-peer file sharing has become a problem. Some users have enabled peer-to-peer clients that have started sucking down lots of bandwidth. GlobalMantic would like to put a stop to this practice. Between this and some other inappropriate uses of the internet, productivity has become a problem, and management is worried about security and potential liability issues that might arise. They feel that HTTP filtering is one way by which web use can be better controlled, and the company can protect itself. By the end of this lesson, you'll understand the different ways by which rules can be configured to include HTTP filters, but you'll also come to realize that this is not an exact science. No network security mechanism that you put in place is ever an exact science. And you'll also understand some other HTTP configuration options that can optimize Threat Management Gateway. So, what's the purpose of what's called the HTTP filter in Threat Management Gateway? Well, think about this. Firewalls are really good at blocking, but with a hammer-based approach. So, let's say that you try to block particular kinds of traffic. You can tell almost any firewall to block based on a particular port or IP address combination, and it'll hammer all the other traffic that doesn't meet those specifications. And you've already seen with Threat Management Gateway that you can go a step further and you can say, well, based on particular destinations of a certain type, by, for example, saying I don't want to allow anyone to go to a site that hosts adult content or gambling content. But that's still sort of a hammer-based approach. It's easy to work around firewall rules with HTTP. And if you think about it, pretty much everything rides over HTTP these days. There are so many different peer-to-peer clients, for example, that leverage HTTP that you can't simply block HTTP just to block those clients. I work at a college. We have firewalls. And let me tell you some of the ways that our students can work around whatever rule we put in place, sometimes, to try to get what they want. So without going crazy, we've got to find ways to address some of these issues. And if you think about it, HTTP is used for everything. It's used for peer-to-peer file sharing systems, although sometimes they use different protocols. But HTTP is also used for legitimate uses, obviously, with your typical web browsing, but some enterprise services. So for example, some of the Exchange services ride HTTP. Outlook Anywhere used to be called RPC over HTTP. Basically what happened is Microsoft would encapsulate remote procedure calls, RPC, inside HTTP traffic, which was then encapsulated inside TCP/IP, and it would ride the wire to its destination. And this way, Outlook Anywhere would work through firewalls, through routers, the whole 9 yards. But it's another example of ways that HTTP can be leveraged in a way that maybe it originally wasn't intended to be leveraged. And examples of this use abound. The HTTP filter allows you to protect your network or restrict its use with just a little bit more precision. You can actually scan and modify HTTP requests and responses. And you can actually block certain HTTP responses from even working at all through your network. And with HTTP settings in Threat Management Gateway, you can manage data encryption and compression settings that can do a little bit more to protect your network and be a little bit more efficient while it's doing it. I've sat here and talked quite a bit about what the HTTP filter does, and before I continue, I want to tell you exactly where to find the HTTP filter on a Threat Management Gateway system. So I'm going to go over to the Threat Management Gateway console to continue. And here we are. You'll notice I've selected System, and I've gone to the Web Filters area. HTTP filter is a web filter in Threat Management Gateway. And number 12 on the list is an HTTP filter setting. And if I open this up, you'll notice that this says that it filters HTTP traffic and enforces configurable HTTP policy. you can configure your HTTP policy based on criteria that you need for your organization, and the web filter handles all that traffic, and the relative path is just a DLL that handles this. By default, this filter is enabled. If you disable this filter, any filtering properties you have on any rule will simply not work. They'll be disabled. Basically, everything will be allowed. So, what are some of the common scenarios under which you might use or configure HTTP filtering? So, you might have a client that's protected by a threat management gateway server, for example, everything on the internal network, and these clients are accessing HTTP-based content on an external network, generally the internet. Or, you might have a client on an external network that's accessing a web server that's being published by Threat Management Gateway. In either case, you're going to have a rule that allows HTTP access to those resources. In either case as well, you can add communication restrictions in the form of an HTTP policy. Now, I want to mention that most settings are specific to a single rule. So on a per rule basis, you can actually change the overall way that HTTP is going to operate. But there is one setting, the maximum headers length, which we'll talk about in a little bit, that's a global setting that's configurable through a generalized HTTP policy. About the HTTP policy settings that you have at your disposal. Before we actually go through the policies, I'm going to go over to the console to show you where you can actually make some of these modifications. So I'm going to go to the firewall policy area, and I'm going to choose this allow web access for all users. And I'm going to right-click this rule, and I'm going to choose Configure HTTP. And you're going to see that I get a window that says Configure HTTP Policy for the rule. And there are 5 tabs across the top: General, Methods, Extensions, Headers, and Signatures. So what do all of those actually mean? On the General tab, the first item is maximum headers length, which is a value in bytes, and the default is 32,768 bytes. This is a global header length, and this is the maximum length of a URL and HTTP headers that Threat Management Gateway will allow. If you're browsing or a user is browsing to a site that has a URL and HTTP header length that goes beyond 32,768 bytes, Threat Management Gateway will simply block the request. This is a technique that you can use to try to block overflow scenarios. Basically, a website might try to ram so much down a browser's throat that it creates an overflow condition that could leave the browser or operating system vulnerable to attack. And that's bad. The next item, allow any payload length. The default is yes. In other words, the checkbox is selected. If you specify a setting, this limits the amount of data that a user can post to a website. When not selected, basically, when you deselect that item, you also have to specify the maximum payload length. By default, a user can post as much as they want using the HTTP post method to a website, and Threat Management Gateway is not going to try to block it because there's no set configurable item for, or no configured value for the maximum payload length in bytes, and you're allowing any payload length. Next up, we have the maximum URL length, again in bytes, with a default of 10,240 bytes. This limits the length of the URL that's being sent by the client. Now, we also have the total length of the URL plus the headers of 32,768, but what this is saying is that the URL portion cannot go beyond 10,240 bytes. Again, this helps to prevent overflow conditions from taking place. The maximum query length. Now, if you've ever looked at a URL that might do database calls or pass parameters to a website to do database calls, you'll see that there's a question mark in the query in the URL that says this is the query portion of the URL. Well, there's a maximum query length, which again is 10,240 bytes. This limits the length of the query being sent to the client or by the client. When you verify normalization, when you have this option selected and it's not enabled by default, this can help protect against what are called malformed URLs by blocking those that have escaped characters after what's called the normalization process. Normalization process replaces strings such as %20 with a space. What happens in the normalization process is these queries are processed twice. If after the second pass there are still escaped characters, then the request will be blocked. But again, by default, this item is not enabled. If you select the block high bit characters option, which is not enabled by default, this is going to block URLs that contain what are known as double byte or Latin 1 characters. In other words, characters that use more than 8 bits on it per character. In the ASCII character set, each character uses 8 bits, or it's 1 byte. However, choosing this option can create significant problems when you're publishing certain kinds of content. So have a darn good reason before you decide to choose this item, because if you go ahead and select it, you could create some problems for yourself if you're publishing certain content from your threat management gateway system. You can also choose to block responses that contain Windows executable content. By default, this is not enabled, but this would block downloading or execution of executable files, which if your users don't need to do that, maybe that's a good thing, but in a lot of organizations, you don't necessarily want to block this kind of traffic. Next up, we have the Methods tab. Now let me go over to the Threat Management Gateway system and show you what that looks like. So we'll right-click a rule, choose Configure HTTP, and then we'll go to the Methods tab. And you're going to see that there are some options here. We have Allow All Methods, Allow Only Selected Methods, and Block Specific Methods, Allow All Others. If you choose to allow only specified methods, you can add methods that should not be allowed, or that should be allowed. And here you're going to add methods that should be blocked. So what does all that mean? Well, what do you want to do? Do you want to block post, for example, so users can't provide content to external sites? This way, some organization might choose to disable posts so that users can't upload what could be sensitive business information to other websites. But there's lots of things you can do with the methods information to help protect the organization. On the Extensions tab, again, I'm going to go over and show you what that looks like. You have to decide what you want to do here. Do you want to allow all extensions, allow only specified extensions, or block specified extensions? And those are pretty self-explanatory, but there's also an option there that says block requests containing ambiguous extensions. This by default is disabled, but what happens is if Threat Management Gateway can't determine a file extension, then it will block the request. So if a file extension that Threat Management Gateway doesn't recognize comes through, then it will block the request because that could be a way that malware is trying to infect your system. This tab allows you to block specific kinds of files. So maybe you want to block the downloading of MP3 files from the internet. This is how you can do that. Next up, we have the Headers tab. Let me go over to the console and show you that. And here we have 3 areas. We have the Allow All Headers except the following. And then we have server header handling and a via header item, which we'll just explain in a second. So we can choose headers that we would like to handle or disallow. Now, headers are going to be very specific to the organization. Now, you might have a header that says, let's say we have a publishing rule out there, for example, and one of the headers that comes back when an external visitor visits one of GlobalMan6's web servers is the kind of web server that it's being run on. In the case of GlobalMan6, this would report back as being an Internet Information Services 7 server. Now, in some organizations, they don't want visitors to know what kind of web server is the platform of choice because that can help attackers gain insight into what kind of web server needs to be attacked. It basically narrows down the option. So you could replace that header with a generic piece of content instead. And so instead of reporting back IIS-7, it would report back none of your business or a web server. When we get to a server publishing rule later in this course, we're going to actually create an HTTP header policy, an HTTP policy that does just that. For now, we're not going to do too much with HTTP headers. We have 3 options when it comes to the server header. We can send the original header, strip the header from the response, or modify the header in the response to the client. Via the header, we can also send the default header or modify the header in request and response. This area will make a little bit more sense when we get to an example in the server publishing lesson in this course. Every application has a signature. You can actually block content containing signatures. So you can block application access using these specific signature strings. This allows you a very granular ability to block specific content. Now, when content is encoded inside HTTP, this is where you get the signature information. This is, however, certainly not foolproof. There are 1.5 million, possibly 2.5 million different ways to work around this, but every barrier you throw up in front of people is just one other barrier they have to get around, so this may work for some folks. GlobalMantix is going to attempt to block peer-to-peer applications through the use of application signatures. Further, GlobalMantix will also modify a rule to block the download of WAV files, files with extension of .wav. So, we're going to go over to the GlobalMantix Threat Management Gateway Server console, and we're going to configure an HTTP policy that does just this. So we're back at the console, and I'm going to go to our allow rule here, and I'm going to right-click it and choose, well, not that, but I'm going to right-click the rule and choose Configure HTTP. I'll go to the Signatures tab, and I'll click the Add button because I want to block a content item based on some criteria that I specify. And we're going to call this Block Kazaa. Don't really need a description. We want to look in the request headers. This is where we're going to find the user agent string. And that's the HTTP header we're looking for. And for this one, there's lots of different ones we can use, but for this example, I just want to use Kazaa. And that's it. Now, if a user, well, once this policy is applied, if a user tried to browse to a Kazaa site and they were using, and the user agent string came back with a Kazaa, then the content would be blocked. And that's a good thing. I don't have a real easy way to test that one, but the next one we do have an easy way to test. And that's because we want to block WAV files as well. So once again, we're going to right-click this rule and choose Configure HTTP. This time, we're going to go to the extensions area, and we're going to block specified extensions, allow all others. I want to click Add. An extension is going to be WAV, and we'll block WAV files. And we'll click Apply, and OK. Now, we have to go over to our Windows 7 machine and try to browse and find a WAV file. But first, let me apply the setting changes. And we'll click OK. So I'm going to go over to the Windows 7 machine now. I'm now over on a Windows 7 machine, and I've already browsed to thesoundarchive.com and identified a WAV file that I'd like to download. And when I hover my mouse over the file, at the very bottom of the screen, you can see that this is indeed a WAV file called shakebake.wav. And when I click this file, I get a network access message that's saying this page cannot be displayed. And the reason is it's a proxy error. The request was rejected by the HTTP filter. Contact your Forefront Threat Management Gateway Administrator. And the source was the web filter. But how do we really know that that was the case? I'm going to go take that WAV extension rule out, and we're going to try this again. So this time we'll go to Extensions, and we'll just choose Allow All Extensions and click Apply. And we'll apply our settings, our changes. And now I'm going to go back over to the Windows 7 machine, and we're going to see if this file will download. I'll start a new browsing session. Again, unfortunately, the changes it takes them a few minutes or at least a few seconds to resolve. So, and this time I get a message from Windows Media Player saying, "Do you really want to download this file?" So rather than getting that error message that we got before from Threat Management Gateway, this time we actually do get the Windows Media Player, which will play this file exactly as we're supposed to. So this shows you that by putting that WAV file extension in place, we were able to block a specific file type. And that's a very, very good thing for those that need to block, that don't want particular kinds of files on their network. Before I move on, let me talk a little bit about why this is not foolproof, the signature stuff. The reason is because applications that try to get around things are by default going to try tricky things to get around it, right? So they can actually fake the user agent string or things like that. And so that they can say, well, I'm not really Kazaa, I'm really Windows Live Messenger, or I'm really Yahoo, or I'm really something other than what I really am. So relying on those kinds of signatures alone is not going to get you very far. Again, this is just another hurdle you can put out there, but it's not foolproof. Now, let's talk about compression. When enabled, which is the default, Threat Management Gateway uses what's called gzip for compression for HTTP content. In HTTP 1.1, this is standard. If you're using HTTP 1.0, which not very much does these days, that's going to be a little more difficult because it's not there. When something is compressed, it reduces the amount of data that's transmitted over an HTTP stream by compressing and deduplicating the content. So it uses two methods to try to reduce the amount of information coming across the wire. This kind of compression is pretty standard these days. It requires a little bit more overhead on both the server and the client, since there's a compression and decompression process that has to take place, but bandwidth is the expensive part these days, not processing power. Microsoft supports gzip-based compression in HTTP 1.1 communication in Windows 2000 and later operating systems, as well as in every version of IE since IE4. Some content types, however, can't be compressed. So, in other cases, data might be streamed rather than downloaded. And those kinds of content are not compressed. So, what kind of content can't be compressed? Well, a zip file. A zip file is already compressed. Trying to compress it again is only going to add overhead and actually make the process more inefficient than anything else. And again, some data is going to be streamed rather than downloaded, and that may not be compressed either. Compression and caching can work hand in hand too. If you're caching content, it could be compressed, which is good because the caching mechanism is intended to try to save your bandwidth. So using compression and caching together can have a bigger bang for your buck than just using one or the other. We'll be talking about caching later in this course. HTTP compression is handled by two web filters. I'll show you those web filters right now. So from the system area, go to web filters, and you can see compression there and caching compressed content filter. So we have compression, which is going to enable HTTP and HTTPS compression. And we have the caching compressed content filter, which enables caching of compressed HTTP content. Working together, those make for an efficient system. The compression filter is responsible for compression and decompression of all web requests and responses, both HTTP and HTTPS. This filter has high priority because decompression must take place before any other web filters can inspect the content. So that list of web filters that you saw are actually used in order. The reason that the compression filter is high is because none of the other web filters can do their jobs with compressed content. The caching compressed content filter is responsible for caching compressed content and serving a request from compressed content in the cache. This has lower priority because caching can take place after everything else has been done. So once you've decompressed the content, once you've run it through your HTTP filter, that's when something can be cached. You don't really need to worry about it early on in the process. Now let's get to the meat of configuring HTTP compression, which is handled through the HTTP compression window that you can see on your slides. There are really two tabs in the HTTP compression window that are of interest. The general tab is just like most things in Threat Management Gateway, just an overview of what's possible. First of all, the Return Compressed Data tab is used in web publishing situations, but you can add exceptions and you can add your own rules manually if you like. And you can also choose content types that are subject to compression, and I'll show you that in a minute when we get to the demonstration. Now, what I mean by it's used in web publishing situations, what this means is that when you publish a service out to the internet, those services will show up on this tab as having been published with returning compressed data out to the client. So basically what will happen is the clients that make any requests to the services that are published and listed on this tab will undergo HTTP compression in order to make more efficient the network communication that's going on. We're not going to be doing too much with the Return Compressed Data tab here, but I am going to show you that there are a couple of entries on that tab on the Global Mantic system because I've recorded these lessons out of order. So some of the things that I've published already, for example, Outlook Web Access, you'll actually see on the Return Compressed Data tab. What's more pertinent for our purposes here is the Request Compressed Data tab. When content is requested from requests that are on the specified network, that content will be requested to be compressed. Does that make sense? Remember, this is just a request. If the other system does not support compression, the data is simply going to be returned uncompressed. That's not a bad thing. It just means that it's going to be a little bit more content than would otherwise be downloaded. Now, it's important to keep in mind here that you have to put the target networks in the white area you see on this tab. And the reason for that is because any content that's requested from those networks will be requested as compressed. Now we're going to go over to the Global Mantic Threat Management Gateway system, and I'm going to show you how to make these configuration changes. Here we are over on Global Mantic Threat Management Gateway system, and I've gone to the Web Access Policy area, and you'll notice that I have the Tasks pane selected. In the Related Tasks area of the Tasks pane, you're going to see an item called Configure HTTP Compression, which I'll click. And you'll see those three tabs that we just talked about. General, which basically is going to be the place where you enable HTTP compression, or disable it if you like. And then the Return Compressed Data tab, which as you can see, I've got a couple of entries there because of the 2 web publishing policies that I've got in place. And I could add more if I like, or I can make exceptions, but I'm not going to do that in this lesson. But the one I'm most interested in is the request compressed content. Actually, let me go back here for just a second. Remember the content types I talked about? If you want to choose which content types are going to be compressed in a web publishing situation, you can do that by clicking on the Content Types button at the bottom of the window. And here you're going to notice the only kind of content we're going to compress are HTML documents and text. In general, HTML documents and text are highly compressible, so there's a lot of benefit to compressing those content types. Other content types are also highly compressible, but it really depends on the content type. For example, MP3 files are not always all that compressible because a lot of times they're already compressed. But you may find the application data files are compressible and things like that. But by default, Threat Management Gateway is only going to compress HTML and text documents. On the Request Compressed Data tab, remember I indicated that you have to choose which network you want to be the subject of your compression needs. So we're going to click the Add button, and we're going to simply add the external network. Because remember, this is a client access scenario, so in general, those clients are going to be accessing internet-based resources, which are on the external network. And we want to compress as much of that as possible. And we can click Add. And if I wanted to, I could add the perimeter network or anything else, but we're not going to do that. We're simply going to choose the external network, and we're going to call it a day. We'll click the Apply button, and we'll click OK. That tells Forefront that we intend to make changes to the HTTP compression settings. And as we've always had to do, we'll then click the Apply button. And if we want to type a description, we can, but I'm just going to click Apply. And those changes will then be applied to the firewall settings or to the web access policy settings on the Threat Management Gateway system. Finally, I want to talk about what's called DiffServ, or differentiated services. Threat Management Gateway can prioritize traffic based on the Differentiated Services Protocol, otherwise known as DiffServ. This protocol can be manipulated, however, to artificially increase prioritization. I want to make that clear up front. Nothing you do, again, as I've said before, is going to be foolproof, and this is another example. But again, this is the steps you take for those that are willing to stay inside the boundaries so that they enjoy the quality of service or the prioritization techniques you put in place. Threat Management Gateway supports global packet prioritization. DiffServ is not enabled by default in Threat Management Gateway, but you need to be aware that it exists, although Global Mantic does not use DiffServ. What DiffServ allows you to do is basically prioritize certain kinds of traffic for quality of service. There are certain kinds of traffic that you need to be able to differentiate. For example, voice over IP traffic needs to be prioritized over non-real-time traffic because voice over IP is very latency sensitive. Someone on the other end will hear it if your latency starts to go too high because Threat Management Gateway is serving other requests. Remember that DiffServ prioritization is based on request headers from clients that are cooperating. If there are non-cooperative clients or that they adjust their headers, their traffic may receive a higher priority than intended. So, Again, just like you have the case where malfeasance can modify user agent strings to get around your priorities, those that want a higher quality of service for their traffic could do something similar with diffserve. I'm going to go over to the Threat Management Gateway system and show you where you configure diffserve, although again, GlobalMantics does not use this service. So again, from the tasks area in the web access policy, I'll go to Configure diffserve Preferences. And you're going to see that there are a number of items, 5 items across the top of the page. We have the general page, which allows you to enable the service if you like. Supported priorities and diffserve values. You have a priority, diffserve, and size limit. You can choose priority name and diffserve bits. This is going to tell you how to configure the particular service. You can actually have priorities for certain URLs. So if somebody's visiting a particular URL, you can give it a higher priority if you like. You can also do the same thing with domains and networks. Now, what this allows you to do is basically apply your quality of service settings to traffic from these URLs, domains, and networks. But you have to configure your priorities first. We're not going to get too much into diffserve here. It's not something that's all that pertinent to what we're discussing. And GlobalMantics has chosen to not use this because they do not need to do anything with priority of service. We started with a discussion about the purpose of the HTTP filter, and then we discovered a couple of scenarios under which the HTTP filter can be useful. Once that was done, we moved on to discuss the various HTTP policy settings that are at your disposal in the Threat Management Gateway console. And we wrapped up with a discussion about HTTP compression and a quick overview of diffserve to raise your awareness that this protocol is available in Threat Management Gateway. Thank you for listening, and I look forward to seeing you in the next lesson.